Your test Thursday, this is included. Okay, so let's talk about before we talk about use substitution, let's talk about overestimate and underestimate. If you ever have, sometimes they will ask you to justify, are they over or under? So for example, if today I have some questions, I says f of x is equal to 9 to the x plus 2, something like this, from 0 to 2, and there was 4 sub intervals, right? So I think we talked about this in this period, I think last time, right? Something similar to this, right? We talk about, are they over or under? So first of all, let's talk about left Riemann sum, and second, let's talk about right Riemann sum. And third thing, let's talk about the trapezoid rule. I can talk about midpoint as well. But midpoint, I can only do 2 sub intervals. That's the only one I have to do a little bit less intervals. Okay, so I want you to work out this, and I want you to tell me, are they over or underestimate? Okay, so, and justify. Are they over or underestimate? Over or underestimate? Over or underestimate? And justify on all of them. Justify on all of them. Okay, so Andrews make me really upset as well. I don't have time for immature kids, really. Andrew Lopez.
Please leave your name, number, and a brief message.
So the first 3, I want you to use 4 sub intervals, and the last one, then you use 2.
Over on
Because I remember doing like the
how do you know that? I just drew it out and then just put some pills on graph. I wouldn't tell you. Just on an explanation. You think left would under any sense because exponential would in here would already be under and right would be over because the right side would be yeah, left side would be under the graph. Right side would be over the left side. Trapezoid. I think it'd be over because that would be because and midpoint, that's just over, yeah. I guess they're trying to find the actual on the scale. They make a lot of time. I drew a graph.
That's for those.
I drew a graph.
What is the graph?
Line is over.
Oh wait, but that still applies here, right? So
Probably this is necessarily for
Line over curve.
who you win.
where we go, can I ask you a question? Or is it points 1.5?
The trapezoid matter?
X squared is
For-
1.5 and y is 29.
Yeah, so that double prime matters for wait, prime matters.
Okay, I don't think it's a graph, but you just have points.
I just
I just drew kind of like a model of what it would have.
Oh, I talking about
something fine for
no 1.5. Is that would be 29?
Thing is, if you look at it from the block, you think that's what the something like.
and then match it with the trapezoid. It'd be the slope.
You didn't read.
When the left side is also
It's talking about the look at this. You have like 0 here, you have like 1. This point, these 2 points back, and then there's this right here. Under this is under
This is trapezoid, which also always.
It's easy.
Yeah,
You're drawing a copy of that.
my head.
I don't have to draw it.
All over.
If I were to draw a graph everything.
No, next 0.
That's the last one. But the thing is, you have to justify it. I justified it via the graph. You can justify it via numbers.
Oh. Okay. I get it. So it's over S.
All right, so let's go over it. First of all, if I give you a function, I'm not giving you a graph. Now this is a regular interval. So what you can do is actually just establish the table. So I'm gonna do x and y here, 0, half, 1, 3 half, 2. 0 is going to give you what?
Hey. 3.
Half is going to give you what?
5.
11. And 3 over 2 is
29.
and it's 83, right? So then left Riemann sum is gonna be half times 3. Well, I'm gonna do it this way because it's gonna distribute anyway, so it's gonna be 5,
The top up on the screen, we can't see the middle of it.
11, and 29.
Yeah.
And then you're gonna get the answer. Now, are they over or under?
Under
Underestimate,
24.
but why is under?
Because if you look at this badly drawn graph,
I don't really care about drawing. I don't care about how you draw it. You want to go with the rubric. The rubric is saying what on here? Lucas?
what rubric?
The rubric will be f prime of x is greater than 0. Rather than f of x is increasing, you have to write down the calculus. Because the f of x is increasing, that's algebra. Right? If calculus, this means f. I know what you're trying to say is f prime of x is greater than 0. The same thing, but it's in terms of calculus.
Oh, then
We write f prime of x is greater than 0.
Yeah. And this one is gonna be 1/2 times 83 plus 29 plus 11 plus 5, but I didn't use the first point. Now this one's gonna be over. Again, this is f prime of x is greater than 0 because if you're over, if you have a function that's going up, right? If you use the right end, you just need to draw 2 trapezoids. That's why I talk about drawing is so important, because drawing to help you figure out the answer right away. Now you could have going under, right? If it's something like this, if the right end is gonna be under estimate, if it's decreasing. So it's really based on are they increasing or decreasing, like what Lucas said, but we cannot say it's increasing or decreasing. We have to say f prime of x is greater than 0, f prime of x is less than 0. Does that make sense? Trapezoid. Okay, so trapezoid is going to be each individual one. So I plus 5 over 2. Well, that's the base. Sorry. I don't need 1/2 here. Times the height is half. Oh, I can do a half in the front. So I can do that. Plus 5 plus 11. Plus 29 plus 11 over 2 plus 29 plus 83 over 2. But it's going to distribute to all of them, so it's going to be the height of each triangle times the average of the base. Now, is this over or under, Chase? Why? Graph is concave up, but you cannot say that.
the second derivative is greater than 0.
Great. So that will be a better way to justify. You cannot say it's concave up because, well, I guess you could, but I don't know if they will give you points. I don't think so.
All the justifications have to be
Just yeah, in terms of calculus, because concave up still pre-calc. Okay. Now midpoint of a trapezoid. Now midpoint is kind of interesting because you use this. If we would have used 2 rectangle, then you wouldn't use any of those 3 values. But the problem is midpoint, so it has the middle of 2 points. But also pay attention to width are different this time. What is the width this time? It's 1/2. It's 1 times 5 plus 1 times 29. And that will be the approximation for this particular one. Because use the middle of the 2 point and use 2 subinterval. Because if I use right or left, it's gonna be 0, 1, or 2, right? If I use left, it will be 0 and 1. If I use right, then it'll be 2 and 1. But the problem is I use middle, then that's that. But change the width because width is different. Width is not the same as before. Now, is this over or underestimate? Well, the truth is,
It's over, but then.
the truth is it's not clear enough to justify anything. Midpoint is the only way. The only thing is they cannot really clear justify. If you really calculate it, it's under everything else, I believe,
It's
because you use a 5 and 29, and you are gonna be way under compared to everything else, I believe. But you can calculate it. I don't know.
it's greater than left.
Could be greater than okay, 5, 3, 8, 19. Is it greater than left? Okay, so it's greater than left, but it's not enough to justify anything because the middle point doesn't really have a way to justify anything. Now, this is what AP exam want. I don't really care about this. I don't really care about over underestimation, but I do care about you understand like why they are over or under. But for AP exam, those are easy points. All you gotta do is write down certain things to get the points. So which is fairly easy.
So if they ask how to justify midpoint, we just say you can't justify.
No, they won't ask you. But if it's me, I would ask you. But do I ask on my exam? Probably not. But I will ask you as a person. I would say, hey, why do you think that's not true? Because that's really like understanding in terms of calculus that you have to understand stuff. Okay. So now, it's Andrew on the live stream.
He's doing traditional ones.
Call him to be on live stream. I tried to call his mom, but that's all. Mom doesn't care. His mom's really nice though. I always donate food. But he's gonna fail in physics, doesn't matter what. There's no point in trying.
My mom wants me to tell you that it's not her. I already told her because she's like, I gotta know if I'm going to school again. I was like, sister, you
I don't really care. But you'll be fine. I know you're trying, and the grade will.
she's like,
Tell him to call me if you have any problem. I have no problem. My phone number is always out there. My address is out there. Group of students coming to sing Christmas Carol into my class. I don't really care. But if you're doing what you're supposed to do, you're great. Okay.
Andrew's watching.
All right. So what we're gonna do is a use substitution. Use substitution is fairly easy. There's no chain rule for everything. So there's no chain rule for integration. Again, there is only use substitution. Before I do use substitution, I want to review one last question. Do you guys remember how to do fundamental theorem of calculus? That just say, I don't know, 1 over hold on, that says sine square of x, or sine square of t dt, and that's equal to x squared and maybe square root of x is equal to f of x. And if I want to find f prime of x, how do I find f prime of x? Okay. Yes.
Is it you replace?
Hold on. Work it out first. Okay, so this is before you go into U substitution. I will tell you this is on the test. It's a fundamental theorem of calculus. If this is a variable on a boundary, you are going to get people asking you what's f prime of x. Okay, so you are gonna get usually the derivative of that, usually the boundaries. So this is the one thing before I want to start with the U substitution, which is fundamental theorem calculus. We are coming back to fundamental theorem in calculus, but we're gonna talk about the FRQ for our AP exam is gonna go after the Christmas break. So we're gonna talk about velocity and error volume. We're gonna talk about net rate. We're gonna talk about 3 FRQ questions. The first week we come back for the things. So just by that should give you a 27 points if you understand everything. But this also gonna give you another point, so it's 28. So generally, the first week we're gonna talk about 28 points of AP exam. And if you don't know it, you need to know it. Yes.
How many points do you need to like get a 3?
42. So that's why I say it's not hard. You guys just need to put some work in there. If you guys have already got this far, should not give me excuses why you don't have homework, why you have wedding, why I cannot see the stream, why can I get it done on Friday? If you really have all that excuse, why you cannot come to school because I have 2 double block? No, that doesn't make sense. Start being a real student, start taking care of your stuff, and then you know what? Everything itself is gonna take care of. I will take care of the rest. But you gotta take care of your part. If I put in 100%, then you put in 70, 80%, that's enough to get a 5. And some people weaker in math, you need to put in 100% to get a 3, yes, but there's also very, very likely you'll pass. But you gotta do your part. I cannot deal with non things like people give me an excuse. Did you find an answer?
Did you do the replacement away? Square G.
So first of all, you assume something. You assume that g of t is equal to sine square of t. So you assume that because we are taking integration and then following a derivative. So only thing is we're using a loophole to establish the derivative and antiderivative, because we're gonna take antiderivative first and the derivative second. So we don't really care about what kind of function is this. Now sometimes, remember, the boundary could be one constant, one variable, but if it's a variable on one of them, usually they'll ask you derivative of it. Okay, so therefore I'm gonna say f of x is integration of square root x squared g of t dt. Now if I integrate this and if I take a derivative, if I integrate this g of t, remember we want to take a derivative of both sides, so that's equal to d to the dx of square root x squared g of t dt. Then we're gonna do this part first, which is the derivative, which is that's gonna be capital G of t between x squared and square root x and d to the dx. Does that make sense? No? Okay, if I integrate non-capital G, I get capital G. That's just a notation. So I only need to work on notation because I don't really need to know how to take integration sine square t. Because most of you guys don't know take care integration sine square t. Even BC calculus kids right now, as of right now, they cannot take sine square t. Only maybe 3 students because I taught them on competitions. They only gonna talk about it this week, how to take integration sine square t, because most of you guys don't know how to take So then we just don't worry about it. We just assume that's a g of non-capital G of t, and we integrate it, it becomes capital G. Then we're going to take a derivative, right? But before we do that, let's do fundamental theorem calculus, because that's going to be g of x squared minus g of square root x. I just plug in the upper bound and lower bound. They subtract each other. I already take integrate. And let's say d to the dx of g of x squared times 2x minus g of square root x times 1/2 x to the negative 1/2. So the problem is there was 2 layers. When you take a derivative of this, there was a first layer, the second layer. There's first layer, the second layer. Sometimes it's a constant, that second thing, derivative of the constant is going to go to 0. So which is nice. If let's say this one is a constant, let's say 2, then the whole second term is going to go to 0, because derivative of 2 is going to be 0. So did I take an integration of sine square of t? I did, but I did it indirectly, right? I did it with doing the loophole where I don't really need to know what's integration of sine square of t. I just need to know that integration of sine square of t is some other function that we don't need to know about. Then now we take a derivative of that. So then it's going to be g of x. So now we're going to say, oops, there's no more d to the dx anymore. So now I'm going to plug in here. So it'll be sine square of x squared times 2x, right? Plus g plus sine of square root x squared times 1/2 x to the negative 1/2. And that will be the result of things. And that's it, because I didn't need to know how to take integration of sine square of t. I just do the operations. I only need to worry about what will be the notation, and I have to worry about chain rule. But I didn't need to worry about how to take integration of sine square of t. Now remember, if one boundary is a constant, then that part is going to go to 0, because derivative of the constant is going to go to 0. Yes.
Plus at the end.
What?
Change to a plus at the end.
Yeah, you're right. It's minus. My fault. Okay, it's minus. Sorry, thank you. Is this difficult? Okay, so this is one of the questions that everybody gonna throw up on Thursday. Is fundamental theorem calculus. All of a sudden, people trying to take integral of sine square of t. It's not possible. But since we talk about integration, we're going to talk about what else we can do. So we're going to talk about what's use substitutions. Now, the format is going to look like this, even though you might not understand. And for what it's worth, you might not understand this, because it's really hard for you to write down stuff. But first of all, we know how did this come in play. So imagine if I were to take a derivative of f of g of x, right? What's the notations going to be? Try to take a derivative of this.
I don't even know where we are. It's just gonna be what's under.
No, if I were to take a derivative of f of g of x, just a composite function, what would it be?
Be what's in the integral.
What? No. Tell me from the beginning. So they are layer, right? They are first layer, they are second layer, and there's third layer.
Yes, you take derivative of the f, which would just turn it into a lowercase f.
F, well, we're gonna say f prime for now, and g of x
And then you go to the g of x layer.
times
which
g
just
prime
turns
of x
into g.
times 1, right? Now, capital F prime, we're gonna call it f of g of x of g prime of x. And that's when you take a derivative of a composite function, abstractly, right? So that means if I integrate this, I should get this. Now, knowing that, that's very, very useful. Also, there's another notation is you can assume u equal to g of x, then that's going to be integration of f of u du. Because if you take a derivative of u, it's going to be what? G prime of x and dx. So therefore, it's going to be f of u. Now, for right now, if it doesn't make sense, sorry, this is a capital F. If it doesn't make sense, it's okay. Because when we actually deal with the actual things, it's going to be much easier. So I want you to understand this. But if you cannot, it's not end of the world. You just need to know how it works on U substitution. So imagine that if you integration of this, obviously, do we want to expand it 10 times? We don't have all the time to do that. And there is no chain rule for integration. But there is another way of integrate something without chain rule. That is deal with the composite function. So first of all, what we're going to do is we're going to assume u is equal to x squared plus 1. It's called u substitution for a reason. Now what you're going to do is take differential on both sides. So it will be du equal to 2x dx. Do you remember this?
Yeah.
We did that before. Instead of du dx, we move dx to the other side. Not only that, I can evaluate for dx. Why do I do that? I'm going to show you something pretty cool because that's going to be du over 2x. Now, whatever x, you're going to convert to u. So that's going to be u to the 10th power. Does that make sense? Times 2x, and dx is going to be du over 2x. You see that magically they cancel out. Which is we know how to take integration of this. Which is u to the 11 over 11 plus c. And which is x squared plus 1 to the 11 over 11 plus c. So this is called u substitutions. So let's review everything again. How do I know u is equal to what? General rule of thumb is set u equal to inside the parentheses. So you might want to write it down. In general, like general tips, right? Tips is set u equal to inside the parentheses. So this is general tips because it should work on most cases. It should work on most cases. So that's integration of, I don't know, we're gonna name a function. Maybe integration of, I don't know. Let me see. X squared times x cubed minus 1 to the 4th dx. Now constant can be outside. from a constant can be taken outside. When you done? Okay, so you done? Kushong, you done?
I have no idea what I'm doing.
You gotta take a differential after you're done with U substitution. Claire, you done? Fabian? Naren?
You think this makes
Jaden? Usually U is inside the parenthesis, the argument. It'll help you a lot because that's the first try. 90% of the time you're gonna get the right answer. 90% of the time. Now we're gonna talk about 10% of the time. It's not gonna work, but 90% of the time it'll work. So in this case, what is U equal to? Now what do you do next? Differential here, du equal to 3x squared dx. Solve for dx. Du over 3x squared. Now if you see this, x squared times u to the fourth and dx equal to du over 3x squared. Now what's nice thing is usually if you see this degree difference between this one and this one, they are 1 degree off. Do you see that 1 degree off? If we're 1 degree off, that's what's called canceling. Okay, so that's gonna be u to the fourth du, and there's a 1/3. Now what happens? You can take 1/3 outside because I don't like that 1/3 that's in the front. Kind of confusing. So it'll be u to the 5 over 5 times 1/3 plus c. So it'll be 1 over 15 of x cubed minus 1 to the 4 plus c. Is that okay?
Would it be would it be x cubed minus 1 to the fifth
What?
in the answer?
Oh, this is a 5. Okay, thank you. Now you say, hey, Mr. J, I don't trust you. You just make a mistake. I understand. And I do make mistake. So I am gonna see if I make mistake on this one. After Kuchang help me fix it, I'm gonna take a derivative of this. What happened derivative of this? The 5 is gonna be in the front, right? So it'll be 1 over 15 times 5 times x cubed minus 1 to the what? 4 times what? 3x squared, and plus c is gone. So this 3 and this cancel out with this one. So it'll be x cubed minus 1 to the 4th times x squared, which is the original function. So if you're not sure, now it almost seemed like I make that mistake by purpose, but it's not. It was actual mistake. But Kushang catch me. But if I were to take a derivative again, I should go back to original function if I want to double check. Because antiderivative derivative is a reverse process. And everybody will make mistake here. It's just margin error. Which person has larger margin error? On your SAT, same thing. I was teaching a bunch of 7th grader yesterday how to take SAT. And I was telling them, it just reduces your margin error. You should increase your score. So on a question that you can double check the answer, you double check it as much as you can. Whether do decimals, whether if 2x plus 1 equal to 5, and you're not sure that's answer, you double check it because You'd be surprised. Margin error is about 5%. Even if people knows how to do it, 5% of student will still get a wrong answer. So if on your SAT, if you just double check your answer, you'll increase your score significantly. Does this make sense or no? What? What'd you say? Yeah. Okay, this is an interesting question. That's cosine, sorry. That's a very ugly S.
5 cosine of prime x dx.
Oh.
Uh,
Can we take a baby picture?
I don't know.
see, does that say cosine 5x?
Yeah,
And that's 5 in front of it.
yeah. I don't even have to put a 5 there. Cosine of 5x. Lucas, you done?
No.
Here's my question to you. Do you see parentheses? I see it.
It's
Kushang, don't spoil it for everybody else.
okay.
I see it. Do you see it? There's a reason why I write like this, where the parenthesis doesn't show, but it's there. Otherwise, it doesn't make sense. Otherwise, if you think about always recognize where parentheses is. In math, it's very, if you want to do calculation correctly, always be aware what a parenthesis is. I think that's the biggest myth about math is students don't understand what a parenthesis is. Even in computer science, I think parentheses is super important. Right, a bit? That's way out of my league of computer science. If keep up the parentheses, I can never keep up the parentheses. Where it should be closed parentheses, where it should be open parentheses. Does that happen with all kind of coding, right?
I'm just on one line, 16 parentheses.
Okay, but that's just bad coding etiquette. You don't have to be parentheses on one line.
Yeah.
But you do need to have some parentheses
Oh,
because
you
of,
need both lines.
yeah.
You don't want can't adjust your timing.
Amy, did you see appendice?
That's the thing, you was equal to 5x.
What?
U is equal to 5x.
That's good because there was actually appendice right here. So u equal to 5x, du equal to 5 dx. Now solve for dx because you wanted everything in terms of du. Do you see that magically happen? This is 1 degree less. It was 1 degree outside 0 degree. It doesn't have to have a 5 there. It could have 2. It doesn't really matter. So that's integration of 5 cosine of u, right? And dx is going to be du over 5. Nice. Cancel out cosine of u du. Then that's going to be what? Is sine u or is, you lied to me, Kushan.
Oh, wait, my bad.
Sine of the 5x plus c. And guess what? If you don't believe Kushan, you can always take a derivative of sine of 5x. So Kushan saved me last time by trying to set a trap for me. Okay. Shh. Let me give you a hard one. Square root of 2x minus 1.
Oh, come on.
This is not even hard yet. This is an easy one.
Drop that.
Ashton's like, let me cook. Let me cook.
Square root is a parentheses with a fractional length of it.
Let you cook.
Mine is not a plus. We sent it over to you. It was over here first.
They love white peoples.
Attacking him.
What? White boys. Is it a fly or a fruit fly?
Well, it's probably first. Why is it buzzing, bro?
All right. I'm sorry. Ethan, you done?
No.
Hurry up.
Huh?
Hurry up.
You guys can go ahead.
Is this it?
Oh, no. Take a derivative. Don't believe me? Take a derivative. Yeah, take a derivative and you see if it's right. If you want to make sure if it's right, take a derivative of it. Emerson, you got it?
She's working on it. Your derivative.
If you're not sure, take a derivative of it. Use chain rule. Practice chain rule while you're at it. By the way, what is a parenthesis here?
1/2. Not 1/2. 2x minus 1 and then exponent.
Prashant, you trying to lie to me again. I say, what's inside the parenthesis?
Oh, I thought you said what's the square root equivalent to? He said nothing like that. Mr. A, I can't think today.
Prashant, don't do drugs.
He already does.
It's called I'm getting enough sleep.
Too much Adderall is bad for you.
Yeah.
Okay, 2 dx here. So du over 2 equal to dx. So that's going to be integration u to the 1/2. Then it's going to be du over 2. Do you realize I convert everything in terms of u? Now I can also take out u to the 1/2 du. And then it's going to be u to the 3 over 2 or 2 over 3 times 1/2. Then 2 cancel out, so it'll be 1/3 of 2x minus 1 to the 1/2 plus c. Now, take a derivative of it. Right? If you're not sure, take a derivative of it. If I take a derivative of it, let's say if I double check this, then that's going to be 1/3 times 1/2 times 2x minus 1 to the negative 1/2 times 2.
Okay.
Hold on a second. I just want to make sure. Oh, that's 3 over 2. Yeah, I just read it. I was like, where's the stuff? So this is 3 over 2. Thank you. So this 3 and 3 cancel out. This 2 and 2 cancel out. And this one is 1/2. Sorry. So that's gonna. Sorry, let me do this again. So I'm doing too fast. Thank you, Chase. Okay, so if I take a derivative of this, it's gonna be 1/3 of 3 over 2 times 2x minus 1 to the 1/2. And then times 2. So this 3 cancel out, 2 and 2 cancel out, and c is going to go to 0, so it'll be 2x minus 1 to the 1/2 power, and that's equal to square root of 2x minus 1, which is the original function. So this is just a double checking part. Yes?
I'm a little confused on where the 1/3 came from. Or like the 2/3 thing cancel out.
So if u to the 1/2, integration of u to the half is u to the 3 over 2 divided by 3 over 2, which is 2 over 3 u to the 3 over 2. It's keep change.
Keep split.
Wait, and that's dividing by because that's divided by 3 halves. Oh wait, never mind. First, and then you convert 1/2.
All right.
Wow, that
Okay, let's give you some tricky one.
the easy part. Oh, science for 3x?
Okay. So, it's like you're playing chess. You have to think about 2 steps ahead. You cannot just think about 1 step ahead. So, the way I think about it is this, at least it works for me, is I think about what u equal to, and I take differential inside my head, and visualize that differential, see if it's present in the question. If it does, something will cancel. If it doesn't, that means you did something wrong. So I don't even like move the chess piece first. I think about if I move the chess piece, what will happen afterwards. So I think about what, in terms of, in u substitution, I think about what u equal to, and what's du, before I even write anything down. Because I think about what u has to be, because this one's a more difficult question, what u has to be, and du is going to be within the question. Now, don't forget, there's a couple other things happening here. I see that fly now. It's next to me now. So integration of sine square of 3x times cosine of 3x. Think about what u has to be. And is there cos, is a du, is there to have you have something cancel. So you had to think about 1 step ahead or 2 step ahead. Here probably 1 step ahead, because think about what u equal to. Now don't forget chain rule though.
Don't know how to do that.
Think about what u equal to and think about du. If du is part of the questions, something can cancel. I shouldn't look at me like.
No, my God.
I don't know if I did something.
Now also the square over there, what kind of notation is that? Think about that. Square means what kind of notation? What does that mean in terms of? Anybody know what a u is? Raise your hand. 2 people? Good. I need more than 2 people though. 3 people. 4. Okay. 5, 6. I would tell you u is not equal to x. Because that's no point. Okay, Shaden's got it. Okay, so you got it? You, Alpha, did you got it? Not it? Noreen, you got it? Okay, let me ask some people. Noreen, what do you think u equal to?
Sine 3x.
Why do you think it's sine 3x?
Because of the chain rule thing you said. And I think if you take the derivative of it, it's cosine 3x, which you could cancel out, right?
But you're missing something though. A bit?
I think it's sine squared 3x.
How's that one? The cosine.
I would say no to you. Because actually make it more complex.
Cosine 3?
Yeah, the problem if you do that, Ian, you're gonna only cancel out one of sine of 3x, so that's not it.
I mean, 3x from right? Maybe also work out.
So what I did is I do u equal to sine of 3x like Noreen did. But the problem is Noreen make a mistake is when he did a differential, it should be cosine 3x times 3 dx. Why? Because there was 2 layers. Does that make sense?
Yeah.
So du equal to 3 cosine of 3x dx. Why? Because this part is this part, right? And if I have everything in terms of that, it's going to be u squared cosine of 3x times du over 3 cosine of 3x. Do you see that? It's nicely cancelled out. And u to the 3 over 3. Plus c. And it's going to be sine of 3 to the 3x over 3 plus c. if you want to double check your answer, guess what? Let's take a derivative. This is sine of 3x to the third. I'm gonna take a first layer, which is taking 3 down. 3 over 3 sine of 3x to the square times cosine of 3x oh, this one's 9. Sorry, this one's 9 here. My fault. This is 1 over 3 here. So obviously if I didn't do double check, I would get a wrong answer. So this one is gonna be 1 over 9. And then this is if I do it, see, if I take a derivative, then I'm missing a 3, so this is actually bad. So this one is gonna be sine of 3x to the third over 9 plus c. That's the final answer. If I take a derivative, it's gonna be 3 sine of 3x to the square times 3 over 9 plus c. So this cancel out. It'll be sine of 3x square plus c. So that's how I double check. So anybody got our answer? Owning 2? Owning 3? 4? So they see what happened. They see that this happening. How many of you guys know that u equal to sine of 3x? No? What did you get, Ashton?
I got this 3x.
3x is not good enough because you're not enough to get rid of a lot of things. It actually is still, the problem still complex.
Yeah, I got. I have a question.
Sure.
Like in your final answer.
It got canceled out. The cosine of x here is canceled out.
Oh, okay. Never mind. I thought you took the derivative.
Yeah.
I thought you.
Oh no, let's question it. So let me give you some practice. I'm not gonna give you a very, very difficult one. I'm gonna give you a 5 practice question. So first one is integration of 2 to the 3x minus 1 to the 4th power dx. The second one is going to be 2x plus 1 to the x squared plus x dx. So A, B, C. Integration of 3x squared square root x cubed minus 2 dx. D. This one is going to be negative 4x over 1 minus 2x squared dx. E. Integration of cosine to the 4 of 2x times sine of 2x dx. So after you've done each one, check each other, make sure they got a right answer. Or you can double check it on your own, take a derivative of it.
Can you zoom in a little?
I'll try. You can double check yourself. You can check with your friends. But yeah, there's 5 different integrals here. finish one, check with your teammate or check yourself. 3x squared times x cubed minus 2 square root. And my handwriting's ugly. I don't mind how ugly they are. Yes.
For the second one, can you just split it up?
I mean, you can, but I think it's way easier to use substitution.
What did you get from what?
Let's see.
Okay, good. I'll take that thing, and that is back in front of 15. I got 2 over 15. No, it's just the bottom. Right? Two x plus one is the derivative of x squared plus x. Well, see, and how you try to figure out u because the power of u squared. Oh, yeah. I might wish you.
Fabian, can you open the door for? Can you open the door for?
We need to set it to you, right? We can't protect you that works. And what we can do is derivative, so the derivative of u to the power of u. Yeah, I think we'll leave it right. That's like.
Which one is hard to read?
That has a derivative inside a derivative.
When? No break. You're Chinese. You know there's no break. Imagine it's like 4:30 in a restaurant.
No, I was like sit in the back and just put my eyes. That's all I did. Play Roblox? William, did you play Roblox? I did play Roblox. Oh yeah.
You know when it's 5 o'clock in the Chinese restaurant, you know how crazy that is.
I would be like back all like the like we have a buffet, so people would get like two go, so I would like back the two go.
Yeah, it's like never ending until like what 9:30.
Friday, I think I was there. I like two of some potatoes in the back.
It's a mental strength. It's you much. I will do calculus than doing that all day long.
I like potatoes.
That's right.
For like 2 hours.
Sometimes like I went to a Chinese restaurant, I'm like, I don't know, some restaurants very dirty.
I'm in the back.
Like I said, I'll never eat. I used to deliver Chinese food, Chinese product to the Chinese restaurant. I was like, I'll never eat Chinese food.
It's always
It's the 2x plus 1 times x squared plus x, or to the power of x squared plus x.
U equal to something. Du is within the question.
No, I'm asking about question number B.
Yeah, U equal to something, so du is within the question. I'm gonna say that over again.
I'm trying to figure out if that's an exponent or a multiply.
You have to do your substitution.
I'm trying to read the question. Okay.
Oh, it's 2x plus 1 times x squared plus x.
So that's a multiply.
Yeah, it's,
So it looks like it's 2x plus 1 to the power of.
no, it's multiplying.
How the hell my pencils learn?
We had 20 minutes? Huh? Hurry up. Can you guys finish? Or we got one more thing to cover.
How the frick?
You guys have 2 minutes to finish everything.
Oh.
It should be done like 1 minute each. Where's Emmy go?
No, I'm not. No, it's just, I don't have the time.
All right. U equal to 3x minus 1, du equal to 3 dx, du equal 3 dx. So it'll be integration of 2 u to the 4 du over 3. So it'll be 2 over 3 integration u to the 4 du. So it'll be u to the 5 over 5 times 2 third plus c. Is that okay? So that'll be 2 3x minus 1 to the 4th all the way to 15 plus c. To the 5th power. I keep on writing stuff wrong. Okay. Yen says, I don't know, this is multiplication. They are multiplication, otherwise it would be way smaller. So what u has to be here?
X squared plus x.
Why?
Because 2x plus 1 is the derivative form of x squared plus x.
So that will be u to the first times 2x plus 1 to the du over 2x plus 1. So this cancel out. So that's going to be u squared over 2 plus c. So that's equal to x squared plus x to the 2 over 2 plus c. Is that okay? Am I going too fast?
X squared plus x squared.
So this one u equal to what? Du equal to 3x squared dx, which is perfect because we have 3x squared there, right? So that's going to be integration of u to the 1/2 times 3x squared times du over 3x squared. So this cancel out perfectly. So that's going to be u to the 3 over 2, 2 over 3, plus c. So it'll be 2 over 3 times x cubed minus 2 to the 3 over 2 plus c. Is that okay? Oh, this one's interesting. What are u equal to? So hopefully you see that relationship now. It's 1 degree less. Do you see that 1 degree less? So du equal to, so besides 2 general rule on tips, is usually you look for 1 degree less or u is equal to inside the parenthesis. Or like 1 step ahead. So it'll be negative 4x dx. So du over negative 4x dx. So it's integration of negative 4x. This is u squared. This one's du over negative 4x. So yeah, like Ashton says, it's like I like when things cancel out. Right? And honestly, that's like kind of like it's satisfying to see things cancel out because your thought process work out perfectly. So u to the negative 1 over negative 1 plus c. So it'll be negative 1 over 1 minus 2x squared plus c. I think that's what I got. What did u has to be here? Cosine 2x. Du is equal to negative sine 2x times 2 dx. Don't forget that too. Du equal to 2 negative 2 sine of 2x equal to dx. So now it's going to be integration of what? U to the 4 sine of 2x dx is equal to du over negative sine of 2x. So this cancel out, but 1 over negative 2 is outside. So u to the 5 over 5 is that okay? And that's equal to, I don't know what u is equal to, cosine of 2x over negative 10 plus c to the 5th power. Good job, Amy. You are helping Krishan.
Lifetime of that.
Hey,
You're never.
hey, I'm not done yet. You're not relaxing yet. I'm not done yet. The next question is a lot more challenging. No, it's gonna be way harder than that. Obviously, this question you're gonna get some type of difficulty because if you do u is inside a parenthesis, which is in this case it's gonna be 2x minus 1, right? Now, what happened with is the x is not 1 degree less. It's the same degree as the inside. So there is something else happening here. So let's give you 2 minutes to see if you what to think about in this question. This question is a little bit harder. Now this question is on a test. This one needed some creativity, which is most of your time you guys think about math, it's just brute force. It's not brute force. It's use creativity, figure out how do you think through in details. So this, we have 2 more questions to go. This is the first one. So I'll just give you a heads up. It turns out you're gonna go into loop, like you cannot solve the problem. Did anybody figure out what to do? But I will say u equal to 2x minus 1 is correct. That's the only way you can possibly think about. And du is equal to 2 dx. Is that okay?
Yep.
Now, what do I do after that? So I'm going to get to integration of square root u. This one is going to be du over 2. Does that make sense? And there is x. This is a problem. Any ideas? No, you can't integrate with 2 different variables. What? No, nothing to split of right now. You can take out 1/2 if you want. It's okay. Okay, fine. We might go in somewhere with this, but still the problem is x and du.
Now you need to change the u back to the number.
What'd you say, Lena?
Isn't it? If you put the x squared back, would it be?
Yeah, like put like u plus 1 over 2 equals to x.
Lena's going somewhere. It's called back sub. You sub back because we have an x, right? Can I evaluate for x here?
Yeah.
So u plus 1 over 2 equal to x. So now I have everything in terms of u, but this one is going to be square root u, and this one's u plus 1 over 2 du. Is that okay?
Yep.
Can I take out 1/2 again?
Yes.
Can I distribute the top?
Yes.
Can I integrate?
Yes.
So can I simplify? Does that make sense? Now this one's the one of the harder one. Wait, hold on a second.
That's 2 over 3.
This is 1 over 6. This is 1 over 6.
Yeah.
Ethan? Shut the hell up.
I haven't said anything.
Yeah, you're whining. It's a very negative energy if you like you just complain about it. If you just like says I can overcome it rather than give out negative energy, you'll overcome it. That's how you train your mental strength. You're training your mental strength by excreting, oh, this sucks, or this is too hard, this is whatever. It's always not gonna go anywhere. Always. Now, if you says, yeah, I gotta find a way to overcome, I gotta find a way, even as the last minute of the day, even as when you're tired, you go into prison concert, you are still doing homework, you're fighting. This is the thing about testing your mental strength. It's not, like complaining doesn't help. Sorry, I'm very straightforward. Yes.
What did you get? U to the 1/2. Like going from u plus 1 over 2 to.
This is u to the 1/2. So this one is square root of u, right? And now take a 1/2 outside, so 1/4, right? So if I just integrate, if I distribute this, it's gonna be u to the 3/2, right? Plus u to the 1/2. Does that make sense?
Yes.
I distribute the top. $6 minutes, that's enough time. It's a good thing I have a timekeeper because of those people that just worry about times. But they're not worried about learning. You gotta worry about both. I can teach you a lesson in 30 seconds, so trust me, 6 minutes, plenty time. All right. Shh. Let's talk about this one. This one is probably one of the most things I need to structure you to do in a certain way. So because it's gonna help you somewhere in the future. And you're gonna be like, oh, I know how to do U substitution. But realize that this is an X value. So realize that this is an X value. This is the X value. This is not a Y value. Again, this is the X value. So if you integrate that, it's the X value. But what you can do is U equal to X squared plus 1. Everybody know how to do this. Du equal to 2x dx. And du over 2x equal to dx. Everybody knows how to do this. It's nothing special. Now, the only thing that's new here is this. The boundary. Switch from the x bound to the u bound and stay as u bound. I'm going to say that again. The boundary is going to switch. So instead of 1, it's going to be what? Does that make sense? I plug in 1 into the x squared plus 1 because that's x value. I'm going to change to u value. And the 0 squared plus 1, that's equal to 1. Is that okay? So integration 2 to 1 of u to the third x times du over 2x. The x cancel out. So that's going to be 2 to 1, 1/2 u to the third du. The x cancel out. Now, do you realize that you want to make sure everything in terms of u, including the boundary, in terms of du, don't convert back to x. A lot of people prefer to convert back to x. It's going to hurt you somewhere down the road. Right now, practice, stay everything with u. So then you're going to have 1/2 integration of u to the third is u to the 4 over 4 between 2 to 1. So it'll be 1/8 u to the 4th between 2 to 1. So it'll be 1/8 to the 16 minus 1. So I just plug in as is because I have everything in terms of u. Put in mind it's everything in terms of u. Okay, so now the last one is a hard one for you. So I change your boundaries. If you know how to do this one, you are good for the test. I know now you're probably going to run out of time to do this one, but I'll give you the answer. The answer is 16 over 3. If you did it right, if you didn't do it right, I'll make sure I'll make a video that has this work. But I want you to do it on your own first. This one's the highest. This one's the final boss. This one's the Bowser. At the end of the day. Yes. No, you have a homework. But that way you have enough practice. It's like shaving potatoes. One stroke at a time.
How did you get 16 minus 1?
Because I plug in 2 to the 4th power, I plug in 1 to the 4th power. Because I take out the constant out, I just focus on u. I don't even worry about the constant until later. So you see that 1/2, 1/4 can simplify to 1/8. I get that. If you got 16/3, you're a genius, and you should be fine on the test. If you didn't get 16/3, it's not end of the world. You just need to know how to do normal use substitution. If your mom has a question, totally call me. It's okay.
Like, you just got to check it. I know I have a D right now, but.
No, you don't have a D. You don't have a D. You won't have a D by end. You'll probably end up with a B. My grading is based on what you're gonna get on AP exam. But I'm also looking at the people always do their homework and always doing their things, doing their work, what they're supposed to do. I mean, I'm not gonna go out there hurting your grade. And matter of fact is I want you to have an A because I want you to do well on AP exam. Now, if I let you cut a slack and then give you like a very good grade right now, you're probably not gonna work hard until the end of the year. And that's not gonna work. So I usually want people to work hard until all the way to the end of the year. So I want to keep them in check. So I don't give you A's unless you really truly earn it.
No,
Like got it on A on the test on every single test. Yeah, you got an A for sure. Now, earning a B is not difficult in my class. At the end of the day, is I look at how much you work and you put in, and I'm just gonna give you.
I was in your class.
I can't have two. Okay.
And you know what? Parents always
Yeah,
they like, you know how there's a picture of like people throwing the babies, and when you throw a baby like this, but when the own parents got it, and you feel like they throw a baby like 1,000 feet high.
She just gets a call. Like, the child is in danger of failing, and then she gets all.
Everybody's in danger. Ethan?
I have a concert today, so I can't go to theater.
Oh.
Dan is gonna drive me to do the thing. Maybe 3 days.